talk about computers today. So, modern computing's been around for a little while now, and just about everything and everyone is using a computer in something that they do. It's in our cars, it's in our house, it's on our phones. You're not really doing any type of manufacturing nowadays without some type of computer involved in the process. Everything has some type of basic computer system built into it, and it's using it to be able to do something. But what exactly is a computer? Right? This is kind of the fundamental idea behind it. What is it? So basically, a computer is just something that does simple math. It does computing, and for the most part, computers just do simple, basic 1 and 0 mathematics. And every single thing that you're doing out there, whether it's going across the internet, video games, high-end graphics, any type of application that's out there, you are doing something that is basically coming down to a 1 or 0. And inside of this computer, you have something like a CPU, and taking them into a bigger equation part of the operating system. And that's the basic plan that how everything operates. It's a 1 or 0. It's a 1 or 0, and then you have a programming language that's taking that 1 and 0, and it is putting some meaning behind what order those numbers are in, and then doing something with them. So computers have been kind of around 1800s. It was created around 1832 by Charles Babbage. It's called the Difference Machine. And that was kind of our very first version of what a computer would be. And we're talking about 170, 180 years ago that this was created. And at that time, comparatively to now, didn't do that much, but for the time, that was a massive leap forward in technology. And again, all it was really doing was some type of simplistic math. Modern computing is more based upon what Alan Turing has created. And he was one of many people who come up with a lot of great ideas. But Alan Turing is someone that we should kind of focus on a little bit here. But he was one of the individuals that helped crack the Enigma code. And a lot of what he did created what we consider the Turing machine. And all modern computers, all modern computers that we use in just about everything nowadays is based upon something that Alan Turing created during his work with computer science at the period of time. So we're like 1930s, 1940s time frame. There's a really fantastic movie called The Imitation Game that talks about Alan Turing's life. He's also a very interesting individual in the fact that he was a gay man in World War II. And when this was found out, he was kind of ostracized by society. And the British Empire at the time took away most of his earnings and his titles and stuff like that. Now that has been rectified over the past 70 odd years now, and there's actually whole laws in place dealing with being able to historically bad laws and undoing them. So there's whole laws in place based on Turing's life. He was an extremely smart man, and his concepts came up with what our modern computing is. So when we think computer, you start thinking about that, like, what does the word computer mean? It really is something that does math. It's computing. And a long time ago, before we started seeing these giant server rooms filled with servers that are doing thousands and thousands of calculations per second, there was a period of time this was all being done by hand. Another great movie to watch, Hidden Figures, and it talks about how for NASA's first launch into space, a majority of it was being hand done, where you had these whole rooms filled with women sitting there doing math, and they would hire out or pull positions into these different areas inside of NASA, and that would be their computer. And they would sit there and they would do the math. They would look through all the math equations, do all the math, and then bring it back to them. Okay, this is what's going on. Now, this is right about the same time that IBM was creating the first real, modern day computer server, and it would take up a room It was so big that they had to rebuild rooms around it. You kind of go to the idea nowadays where you build your infrastructure around where you're going to put it. You don't just put things in places. But that's another really good movie to kind of go take a look at, because originally when we started thinking computers, we're just thinking math. And all we did was take that math from a person doing it to an inanimate object that's just passing electrical signals. So that gets into what a computer actually does. So a computer passes electronic signal. And a great one that I always hear is we're at a point in time where we figured out how to crush rocks and send lightning through it. That's a CPU. You have this ultra thin, ultra tiny little chipset, and it's some type of special silicon based object that we found a way to send some type of electronic signal, some type of electricity through it, and be able to calculate data based upon little caches of information that are on there. So a CPU has these little caches on them, and it stores mathematical equations. And as that same equation keeps on coming up, it'll reach out to that cache and be able to solve things quicker and quicker and quicker. All CPU is doing is math. That's it. So our modern day computers have a little bit more than just math, right? Well, you have graphics cards, you have audio, you have all these other things to get you upon time to have some type of graphical display, which is where monitors come into play at. And for a long time, your computers didn't have monitors. Again, back in 1960s time frame, to be able to do anything with our computers, we were doing punch cards. So we create these little punch cards, set them up with other things, feed them to the computer, and the computer should give us back out something. All the way up to now, where we can type on a keyboard, and that keyboard is the input into the computer, and it doesn't have to give anything back, actually. There's lots of ways to input information into a computer, and you never see it coming back out. What's your automobile? That little computer isn't necessarily sending out a lot of additional feedback back to the user. So the more advanced the car is, obviously the more feedback it's giving you. Nowadays, it's focused more along the tires. You have tire pressure, air codes for your engines, because there's a whole suite of software, but hardware that's sitting there kind of monitoring the engine's capabilities of your engine and sending feedback up to your displays in your car. But it doesn't send a lot. But you can plug in little devices into your car, and it's going to pull all the air codes. And that's because there's a computer that's sitting there watching all those different air codes. Computers can come in all shapes and sizes. Small ones that can fit on your wrist, like the iWatch, the Apple Watch, and Google also has their Android watch system. Those are full-fledged computers that sit on your wrist, and most of them are more powerful than computers that help calculate sending our first people into space. You carry around with you a cell phone that more than likely has more power and more capability than what we use when we sent people to the moon. That kind of says something how fast and advanced we are. Modern computers are in everything. You're not watching this video without having some type of modern computer involved in this. You're not going to do much nowadays without some type of computer involved in it. It's part of that whole process of advancing technology. So what is a computer? It's something that does math. It's something that's involved in every part of our life. It is meant to make things easier. We just have to tell it what to do.